Hi guys, this is Sakshi and I welcome you all to my edutech platform, Way to Learn. So we are back solving again the PYQs from differential equations from CSIR-NET Physical Sciences June 2011 to December 2019. We have solved around 9 questions. So let us see the 10th problem. Okay, so please keep practicing the problems. Okay, so let us solve this question. Okay. Now here we have a equation, right? This is a second order differential equation. Now if you notice this equation is similar to Cauchy-Euler differential equation. So if you don't remember this, please go and revise the video of Cauchy-Euler equation, which will be like around the fourth part of the differential equation. I'll also put that in my description, and please check that once, revise that, and then solve this problem. Okay, so this is a very simple equation to solve. You do not have to like go by a linear method. So here, how do you identify if this particular equation is a Cauchy-Euler differential equation or not? By using this particular thing, x square d square y by dx square plus 5x dy by dx plus 3y is equal to 0. That is x square d square y by dx square plus x dy by dx plus y. So just forget the constants over here right now. If any equations of this form, that is x square d square y by dx square, x dy by dx, and then y, if you have any such kind of equation, then that particular equation is a Cauchy-Euler differential equation. So now, for such kind of differential equation, what do? We are going to write this x as e power z. Replace x as e power z, and then replace d square y by dx square as d into d minus 1. Okay, and dy by dx as d. Now we are going to replace that, x square x. So replace x square d square by dx square as d into d minus 1 and x dy by dx as d. And this is e power z. Okay. Now we are just going to replace that. I'm just replacing this by d square minus d. Okay. So this is d square minus d plus 5d plus 3 into y equal to 0. So this is simplified as d square plus 4d plus 3 is equal to 0. So auxiliary equation is m square plus 4m plus 3 is equal to 0. And my roots will be like m is equal to 3 and m is equal to 1. Real and unequal. So my solution will be y is equal to a e power z plus b e power 3z. Now this is the solution. Just see the options if they match. No, everything is in terms of x, but we have everything in terms of z. yz. Okay, yz, because I have replaced x by e power z. So you can't put e power x over here. It is e power z. You'll have to remember that. Okay. So now I'm going to replace this e power z by x again. So I will get a x plus b x cube, right? So I can write the solution as ax plus b x cube. Let us see if there is any kind of option C satisfies. So this is a very simple equation. You just have to identify if it belongs to Cauchy-Euler differential equation or not. Let us jump to the 11th problem. Again, differential equation. Okay, from June 2019. So see, this is a simple first order differential equation. Now, I'm going to divide that particular equation given in the question by x in order to bring that in a known form. Okay. So now p will be 1 plus x by x, or it can be written as 1 by x plus 1. Okay. And then q will be e power minus x by x. Now we'll have to find integrating factor, which is e power p dx, which is e power integral 1 by x plus x dx. So I can write this as e power ln x plus, sorry, this is 1, e power ln x plus x after integrating. So this exponent can be written as integrating factor is equal to e power ln x dot e power x, which is equal to e power x dot x. This gets cancelled, you'll get e power x dot x. This is your integrating factor. Now I can find the solution y into integrating factor, which is e power x into x, is equal to integrating factor e power x dot x into q. What is our q? Q is e power minus x by x. So into e power minus x by x dx plus c. So you will get y e power x dot x is equal to x plus c. You'll have to find the constant now using the boundary condition that at x is equal to 1, y is equal to 0. At x is equal to 1, y is equal to 0. So 0 is equal to 1 plus c, which is equal to, which gives you c is equal to minus 1. Now use this over here. Y is equal to, okay, y e power x dot x is equal to x minus 1, which will be equal to x minus 1 divided by x e power minus x. Let us see if there is any kind of option over there. Yeah, option A. Y will be equal to x minus 1 by x e power minus x. Very simple equation, simple and easy to solve, which was asked in June 2019. Okay, so let us see the last problem, which is from June 14. I missed this problem in between, so I have added this now. Okay, so this is a second order homogeneous differential equation, right? So we can write the equation as d square plus 2d plus 1 equal to 0 into, okay, x is equal to 0. The auxiliary equation will be 2m plus 1 equal to 0, and m will be minus 1 comma minus 1. So these are real and real and equal. So for real and equal case, what do we have to do? The solution will be of the form x is equal to a plus bt e power minus t, because here m is minus 1. Okay. So now in the question we have that x of 0 is equal to 0. Okay. So at t is equal to 0, x will be equal to 0. So a, we get a to be equal to 0. Now other condition is that at t is equal to 0, x dot will be equal to 1. Now we'll have to find x dot. X dot will give you minus e power minus t a plus bt, just UV method, plus b e power minus t. So now at t is equal to, applying this condition over here, so at t is equal to x dot is equal to 1, which is equal to e power 0 is minus 1, a plus 0 plus b e power 0. We know that a is already 0, so I can write that b is equal to 1 from this equation. Now I know the solution. So my x will be of form t e power minus t. Now let us see what is asked in the question. The solution x of t attains its maximum value when t is. Again, we'll have to find at what point of t will our solution x will get a higher value. But if in this solution you can see here, one t is in the numerator and other t will be in the denominator with the exponential. So you can't find directly substituting a value of t and then getting the like at what value of t does the solution goes to infinity. Okay. So for finding the maximum value, basically what do we do? If you have seen in the classical mechanics videos, you will find the derivative, first derivative equated to 0, find the values, and then find again the second derivative, and at that point you will just see if your particular answer is less than or greater than 0. So at that point you will find at what value of t is your function going maximum or minimum. Okay, that is if your second derivative is less than 0, then you say that at that point your solution is maximum. And when you find that second derivative is greater than 0, then at that point you say that the solution is minimum. Okay, so let us find x dot using this solution. So x dot will be equal to e power minus t minus t e power minus t, and you'll have to equate this to 0. So you will be getting e power minus t is equal to t e power minus t. So t will be equal to 1. Okay, now you got the value for t. Now we'll have to find x double dot. So on doing that, you will be getting the value like e power minus t minus e power minus t plus t e power minus t, which will be t e power minus t minus 2 e power minus t, and you'll have to find this at t is equal to 1, because t is equal to 1 is the equilibrium point over here. If you haven't seen the classical mechanics video, please just have a look at the first video, stability analysis. You'll get a idea like what is x dot and what is x double dot. Okay, but just remember that whenever if you have to find maximum values, you can say maximum or minimum. First step is to find x dot and equate it to 0 and find the points, and then find x double dot and substitute at that particular point, and if it is greater than 0, then this is the minimum value, and if it is lesser than 0, then it is the maximum value. Okay, so now let us see this. We have to substitute the t value. On substituting, we get 1 by e minus 2 by e, which is equal to minus 1 by e, which is lesser than 0. So at t is equal to 1, x will be maximum. Okay, so let us see if there is any option t is equal to 1, which is option B. So I hope you get the solution. So just have an idea and keep practicing these questions. We have solved around 12 questions from differential equation. So in my next video, we'll be solving questions from special function, which is a part of differential equation. So these are not just 12 questions from differential equation. There are more questions from special functions as well. So stay tuned for more videos. Thank you. Like my videos, share my videos, subscribe my channel, and also do not forget to hit the bell. So if you want any notifications in your like in future, then you'll have to hit the bell. So see you tomorrow. Ta-da!